What do an American footballer and a dinosaur have in common? This bizarre creature with its dome-shaped skull had scientists puzzled for over a century. Now they're looking at the all-American sport and re-evaluating the dinosaurs they christened the Boneheads. It is hard to imagine that the lush, rolling hills of South Dakota were once the gateway to hell. But in 1994, commercial fossil collector Mike Trebold uncovered one of the rarest and most unusual dinosaurs to vanish from the Earth. Today, Mike is returning to the place where he made this discovery. Called Sandy Site, it is part of a prehistoric floodplain known to geologists as Hell Creek. His dig is located 650 kilometers from his laboratory at Valley City. Here, 66 million years ago, flash floods killed hordes of unsuspecting dinosaurs. Since then, time and the elements have exposed the richest and most famous Cretaceous burial ground in the world. Out of Hell Creek came the first Tyrannosaurus rex and Triceratops ever found. And at Sandy Site, the last of the dinosaurs made their stand.
One of the things I enjoy so much about the Sandy Site is not only is this where the dinosaurs lived 66 million years ago, but this is the exact place where they died. It's a great Thanatosinos, a place of death.
In 1994, Mike was combing the face of a steep cliff when he came upon the fragments of a dinosaur embedded in clay. They belonged to the dome-shaped skull of an elusive bonehead. Above the clay was a layer of sand, key evidence that a catastrophe had swept away everything in its path.
The Sandy Site itself is contained within this region right here. This sand above is virtually barren. This clay cap contains millions upon millions of plant fossils, and virtually all the bones are found from here to the clay base that I'm sitting on. This is the tibia of a small carnivorous dinosaur, still in the ground. And what makes it extremely difficult here at the Sandy Site is the fact that not only are these bones not very fossilized, but they're also in damp ground. And so what we have to do is cut around the bone and not actually get to it. And we won't actually know what kind of dinosaur this was until it's been prepared in the lab.
While Sandy Site is a gold mine of Cretaceous fossils, it is a nightmare for paleontologists. Bones of the countless creatures who lived here, turtles, crocodiles, ground-running birds, and dinosaurs, have been crushed and jumbled together into a mass of tiny, unrecognizable pieces. To make matters worse, the fragments are incredibly fragile. The skull caps of boneheads are not rare. They have been found around the world. What has been missing is their bodies. After almost 2 years of painstaking work at Sandy Site, Mike finally pieced together one of the most complete skeletons ever discovered.
At the site, the skull wasn't intact. It was blown apart, like an exploded view. As an example, this particular knob right here, this spike, was all by itself. A few inches over, we found another little spike, and then another piece a few inches later. And all of this was scattered in the matrix. And it wasn't until we were in the lab, preparing and preserving these pieces, and then discovering that they did indeed fit together, that we realized at that time that it was a pachycephalosaur of some kind.
The name Pachycephalosaur means thick-headed reptile, but this creature took it to the limit. Its skull can be up to 20 centimeters thick. Even now, what mystifies scientists is why. The boneheads appeared 130 million years ago and flourished until the end of the Cretaceous, 65 million years ago. These two-legged plant eaters have been divided into two groups based on the shape of their skulls. Some had flat skulls fringed with bony knobs, which may have been used to engage in head-pushing contests. Others had exaggerated domes made up of solid bone with lumps, bumps, and spikes at the base of their skulls. The largest boneheads had skulls 60 centimeters long. They weighed up to 6 tons, and their bodies were the size of trucks. Before Mike Trebold's discovery, scientists could only guess at what these odd-looking dinosaurs were designed for.
This is a weird creature, previously known only from the domes of the skull. With this discovery, we have the skull and its skeleton, which gives us an opportunity to look at what was really going on.
Arguably one of the ugliest, certainly the strangest, and possibly one of the toughest dinosaurs that ever lived, the boneheads have inspired a host of theories, from the humorous to the absurd. When the first fragments of the boneheads were uncovered in the 19th century, some scientists thought their dome-shaped skulls concealed great intellect. Others thought the domes were frivolous ornamentation, proof that the boneheads had reached an evolutionary dead end and were going senile. But maverick paleontologist Bob Backer thinks boneheads are no mystery.
Boneheads. Why? When the first bone-headed dinosaur was found the last century, it was clear they weren't nearly as bright as their domed forehead would indicate. This dome was not full of brains, it was full of solid bone. Why? A very old idea was these animals had outlived their Darwinian clock. They're revolving every which way, sprouting bumps and tchotchkes and thingamabigs and domed heads for no reason at all. That's an old idea and it's bunk. In fact, this small-brained, armored four-headed dinosaur was a beautifully designed fighting machine.
American football players are human battering rams. Highly vulnerable to head injuries, they wear protective helmets. Boneheads, on the other hand, may have swapped their brains for a 20-centimeter thick skull they could wield as an offensive weapon.
This helmet isn't enough to really protect this delicate box. If you want to tackle with your helmet, you got to lose the brains, which is exactly what this dinosaur did. It's got a dome up here, but there are virtually no brains. The dome is solid bone.
The most widely held theory is that boneheads took part in violent head-butting contests to scare off rivals and predators. Their skulls worked like football helmets to absorb the shock. Not only were they equipped with built-in battering rams, they had phenomenal neck muscles to add power and precision.
Now, to be a really great head tackler, you've got to have really great neck muscles. Otherwise, when you ram the opposing player, your head will come off. Now, this is what I mean. Here's some great neck muscles here. A wonderful trapezius, a really quite superb obliquus capitis, and a rectus capitis posterior to write home about. Great neck for tackling. Now, here is our bone-headed dinosaur. All of this here is for the neck muscle. All of this would be full of the active muscular tissue that would lock that head in when it rams. Now, if we took this guy's neck muscles, they would fit on this dinosaur. This is a 200-pound football player. This is only a 60-pound dinosaur. Pound for pound, then, this is a better neck.
The neck and the skull were subjected to enormous pressures. Like the membrane in a grapefruit, bone cells in the skull radiated away from the point of impact.
Now, grapefruit grow in an interesting way. The sections radiate out from the center to the outer rind. Now, that's soft anatomy. Here's a bone-headed dinosaur. Grows the same way. The brain would be down here, and the bone fibers radiate upwards and outwards to the outer skull cap, giving you an incredibly strong, reinforced cranial structure. Now you take those wonderful neck muscles and this reinforced dome, and now you have a Cretaceous rammer par excellence.
Nature had invented a football helmet 130 million years before man invented the game. Ralph Chapman of the Smithsonian Institution in Washington, D.C. thinks the boneheads were designed to make love, not war. To prove it, he took 29 skulls of one type and measured the domes and brain cavities. The size of each brain was identical, which meant they were all approximately the same age. But some of the domes were better developed, which Ralph attributes to gender. Only males, it appears, indulged in combat.
If the dome of pachycephalosaurs was used primarily for defense against predators, you would expect the domes of the females to be the same shape as the dome of the males, because both need to avoid getting eaten by those predators. The alternative, that the dome was used in sexual combat, such as front butting or butting of the flank, you would make a prediction that the dome of the males would be much better developed dome relative to the female, which has a smaller, flatter dome. In our analyses, the results show exactly that.
Modern animals that compete with each other to attract mates through elaborate sexual combat are usually males. Boneheads probably lived in herds which were governed by rigid social hierarchies. Males may have engaged in headbutting contests to establish dominance and to guarantee the perpetuation of their species.
Males would have the bigger domes because in nature, they would be the ones to fight over becoming top dog, to have the right to mate with the females. And besides, males are the only ones dumb enough to do this kind of behavior.
Scientists now think the boneheads were the bighorn sheep of their day. During the mating season, the mountains resound with the clash of horns. Fighting can last for hours, days, but rarely to the death. Like sheep, the domes of the boneheads may have been visual symbols of rank. The larger the dome, the more dominant the male. But combat of any kind requires strength and endurance. Did these creatures have what it takes? Now a new discovery is challenging the theory of the battling boneheads. A discovery in 1994 of a nearly complete bonehead skeleton at Sandy Site in South Dakota was big news. But it would soon get bigger. When Mike Trebold examined the neck vertebrae, the first ever found, he immediately recognized a problem. While the skull may have belonged to a headbutter, its neck did not. If an animal is the sum of its parts, the skeleton tells the tale. Like a cog in a wheel, every sinew, every bone is designed to work together as a whole. What Mike saw in the fossils was a more genteel creature, not a fighting machine.
This discovery has answered several questions about whether or not pachycephalosaurs could butt heads or not. As you can see, the skull is very large in comparison to the size of the neck vertebrae. And the neck vertebrae also have a very strong natural curve. And as you can see in this model that I have here, in its natural articulation, everything is fine, but when you try to straighten the neck to ram the skull, you dislocate the vertebrae. And they simply could not do that.
While Trebold was re-examining the headbutting theory based on his new discovery, a paleontologist from the University of California at Berkeley, Mark Goodwin, was attacking the problem from a different angle and arriving at the same conclusion.
Headbutting is a popular theory. It's in all the dinosaur books. I don't think it happened. I don't think they're capable of doing it. And I'd like to change that idea.
To prove his point, Mark demonstrates with a pair of bowling balls.
The surface of a bowling ball is very much like the surface of a pachycephalosaur skull, both big and very round. When you have two pachycephalosaurs, two bowling balls, colliding together, they have to be lined up perfectly in order to make contact. If they're not, they'll glance off each other. This is when we have serious problems. This would result in injury to the animals and perhaps death.
On a rounded skull, the target area is so small that even for the most skilled dinosaur, a direct hit would be virtually impossible. Unlike bighorn sheep, a glancing blow could fracture the domehead's delicate facial bones or send it hurtling dangerously off balance.
Pachycephalosaurs have often been compared to bighorn sheep. Well, in fact, they're quite different. The surface area of the skull on a bighorn sheep is large and flat. Same thing with the surface of the horns here. That provides a broad surface for head-to-head contact and prevents misalignment. Pachycephalosaurs have a small, rounded surface. And just because pachycephalosaurs look like they head-butted doesn't mean they behave like bighorn sheep.
Mark also thinks that even if a bonehead managed to land a hit, its skull could not have withstood the impact. Under a microscope, a thin section of the dome revealed they were not as solid as previously thought.
Paleontologists have described the domes of pachycephalosaurs as being solid bone. In fact, they feel and sound very solid. But when you look at these skulls under a microscope, you see a much different structure. In fact, what you see is a honeycomb structure of bone. It's full of holes, just like the theory of headbutting.
An American football helmet is designed to distribute the force of an impact across the surface of a player's skull. But a blow to a bonehead would compress its skull and shatter its blood vessels at the point of impact. After a high-speed collision, a bonehead would surely bleed to death. In 1995, Mark Goodwin excavated the remains of a bonehead called a Stygiomoloch in Montana. It gave him clues to a more subtle form of contact between these ancient dinosaurs.
In our field work, we found lots of pachycephalosaur skulls, and we find lots of pieces too. This is the back of one skull and clearly shows the spike or horn that's located there. But this skull, this was really interesting because for the first time we had the back of the skull attached to the dome and we could see that the horn is at a very low angle.
By tipping the skull down, the horn is pointed up, creating a dramatic and threatening silhouette.
When this animal tilted its head down, it would be very useful for display, but not for headbutting.
An imposing array of spikes and horns bristling from the skull of a bonehead could get any dinosaur's attention. One look, and a rival might back off before risking death or injury from a confrontation. Mark thinks the donning of spikes and knobs were purely for show, to attract females and intimidate rivals. Neck horns could also have been used for protection against attack from a predator by deflecting the blow away from the head. If spikes and horns did not do the job, Mark thinks the boneheads had another trick up their sleeve: their tails.
Pachycephalosaurs are mostly known from their skulls, but I've also been looking at their tails. And what we see are a series of bony tendons or fibers, and this greatly strengthened their tails. So maybe they were using their back ends instead of their front ends for whacking each other.
A tail-whacking bonehead would be the consummate imposter. But Ralph Chapman is not convinced that their massive domes were not used for head-to-head combat.
Look, this bone was definitely made for ramming into something. I don't see them lining up 100 meters apart and charging at each other. Instead, I see them headbutting from close up and wrestling until one of them gets a headache and just gives up.
Perhaps the answer lies in a combination of the two theories. Bob Backer believes their heads were used like football helmets to ram an adversary in the body.
This isn't for head-to-head ramming. With a head like this, you want to aim into your opponent's chest, or better yet, a blunt, disabling blow to the stomach. This is a visceral rammer.
Body ramming, tail whacking headbutters. What a concept. Could a creature like this really have existed? Or were they smoke and mirrors, a fiction of the imagination? Each day, somewhere in the world, real-life drama is being acted out. Two rivals competing for the right to mate and perpetuate their kind begin a dance. They posture to show their best features. Like boxers, bob and weave, jab and spar. Blows to the body are interspersed with threats and intimidating displays. Finally, on some unseen cue, the loser backs away to live and fight again another season. It is as old as life itself. Sex is nature's most powerful drive. Perhaps on some distant shore 100 million years ago, two ancient boneheads paraded their domes and spikes, perfecting a ritual that would transcend time.